Hello, welcome back to Quant Finance channel. So today we are talking about binomial distribution through this app titled as Binomial Distribution Explorer. So here basically we are talking about these two tabs here in the web app, Explore and Engage tab, and then Explanation tab for the formulas. So traditionally, we know that binomial distribution goes by this formula, right? P x is equal to k. This represents a probability of getting exactly k heads or successes, right? We know that traditionally we have been studying the binomial distribution with the flipping coin scenario, right? Where a coin is flipped several number of times and we want to know the probability of getting heads for a specific number of times. So it is a discrete distribution. So the formula for discrete distribution uses probability mass function rather than PDF. For example, in a normal distribution, we were using PDF, probability density function. But if distribution is discrete variable based, then definitely we use a probability mass function, and it is its acronym is PMF, right? And it is calculated like this. NK here means the N choose K, right? So probability N choose K means we can get K heads on N flips. So put it this way. And then probability of K, and then 1 minus probability of N minus K. So this is traditional formula for binomial distribution, right? We have been using it, and basically it requires two inputs from the user. One is number of trials and second is probability of success. So we know that. But today we are getting into a very interesting dimension, and that is we are learning how to use it. It means a binomial distribution and computing PMF, probability mass function, in corporate finance situation. Here we have taken this example of credit defaults actually, right? And we are finding out the probability of having exactly k defaults in n independent portfolios with the default probability of p. So some credit defaults are happening and we want to know the probability of exact number of defaults, and we are modifying and we are using binomial distribution because it has discrete variable, that is number of defaults, so discrete random variable we call it. So this is what we are doing, right? Here n is the number of trials, right? Which is selected by using the number of trials on the slider here. And k is the number of defaults, which can be integer. And it can, or of course you understand, range from 0 to the number of trials, right? And p is of course the probability of default on each trial, right? So although it is a credit default and it does not look like a success thing, but definitely this is probability of success, and this is kind of taken from this slider, right? So this web app is very kind of interactive web app. Here you can use the probability, here you can actually pick up or choose the probability, I should say, for probability of success, which can definitely range from I mean minimum value of 0.01 I have taken to 1, and then number of trials we have taken from 1 to 100. And then definitely this is that probability, and n choose k definitely means that okay, we are computing the probability of k defaults upon n trials, right? So this is the conceptual foundation. This is the mathematical and formula foundation. And this is how the plot is emerging for probability mass function, right? When n is 10 and when probability of success is 0.5, this is the situation which is coming out here. And here the number of successes is 5 when we take it as 5, right? 5 means it is like, okay, 5 defaults, right, out of 10. Then the probability of 5 defaults is 0.2461. Right. So this is very interesting app learning these days. Quantitative finance, right? Quantitative finance is what? Quantitative finance is nothing else but application of quantitative techniques, Python, and data science into corporate finance. So this is how I define it, right? So learning it through programming and learning it through web app is very interesting thing. And here number of trials we have taken 10 and we are trying to find out the number of successes. If it is 5, exactly 5, then it came out to be 0.02 0.2461, which is 24.61% chance is there that there will be 5 defaults if there are 10 trials. But interestingly, okay, let us drag this slider to maybe 100. Wow. So if my probability of success is say 0.57 and number of trials are 100 and I'm trying to find 60 successes, that okay, there are 60 defaults in there, then the probability is 0.0675. So this is a very interesting app where you can choose a number of trials from 1 to 100 and the probability of success, which can go up to 1, of course, and then you can display the probability mass function, and then you can get the probability of a specific number of successes from those n number of trials. And I will leave you with some music and a very interesting message. Please watch it for next 1 minute. Thank you.